All right, hello everyone. My name is Jennifer Droke. I'm a student at OU. I do computer science stuff and mechanical engineering stuff and a lot of robotics research stuff. And yeah, I'll just be going over a very basic intro to Git and GitHub. You'll kind of see like how you'd edit a file or like other files in your project and how you'd actually make them a repository and be able to control all the different versions of your code. So if you're on the live stream, before we started streaming, we just kind of went over installing Git, as well as installing a text editor. You just have to pick one of these text editors, and also making a GitHub account. This slide is in the Slack channel. I just posted it in the Free Code Camp Slack channel, so you can go ahead and download those things and catch up with us. Okay, so we'll first start with the fact that Git is not GitHub. So we'll talk about each one and how they work together. First, we'll start with Git. So Git is a distributed version control system. Basically, when you have a project, your code's going to be made up of a bunch of different files. As you work on your project and improve it or make changes, you're going to have a lot of different versions of your code. And Git is how we keep track of all that and keep everything organized. So Git keeps track of the full history of your code, and it gives you a full picture of your project, and also gives you a bit of control over when you decide that you're done making changes to a certain part of your code, and lets you decide when you want to implement those changes. And for all changes in Git, Git will show you who made the change, when the change was made, what the change was, and why the change was made. Especially helpful when you're working with other people on the same project. Also, Git stores your entire project's files and entire history in what is called a repository. Just think of that kind of like a file that holds all the information on your project. And to cover the distributed part of distributed version control, distributed refers to the fact that whoever is working on this project has a copy of the code on their machine. So you basically have a bunch of backups of your code. And everybody has the code, its full history, and can make their own changes to the code, and then implement the changes for everyone to see later. And last but not least, Git is free and open source, as you've seen from downloading. It costs nothing to use. And a few examples of what Git can let you do. You can work on your code in a nonlinear way, and that basically means that, say you have a project completed. If you want to go back and add a certain feature to a certain part of that project later on, Git lets you do that at any time. You can work on a project with other people without conflicting each other's changes, overriding each other's changes, or without doing double work. You can create an experiment with a potential feature that you want to add in without affecting your code that's either currently running or the code that you just don't want to break because it's already beautiful. And you can easily just switch back and forth between old versions of your code. Like if you have version 1.0, but you're on to like version 3, you can go back to 1.0 at any time for whatever reason. So GitHub. GitHub is an online platform that works with Git. So GitHub gives you a place online to store all your projects, and it still provides the full functionality of Git. So basically, when you'd have a repository on your computer that you made with Git, and it's like your file for your project, GitHub gives you a place to have a remote repository on the internet to keep your project. And if you have a public repository on GitHub, people can find your project. You can find other people's projects by looking up the repository or from looking up your GitHub profile, either on GitHub or Google or something like that. And a little bit more about projects on GitHub. When you have a public repository on GitHub, anybody can comment on your code. So other developers can report bugs or request features. Even your users can report bugs and ask questions about your code. Anyone can create their own copy of your code, and they can make changes to their copy and then request that you review and then implement those changes into your code if they want to. And also, code shared on GitHub helps others learn. They can learn from your projects to develop their coding skills. It can even inspire new projects, or they can build off of your project. And now I'll just go over a few commands that we're going to use when we're going through Git and GitHub. These will make more sense later as we start using them. So this one's kind of by itself because didn't really go with the other categories I made for commands, but touch followed by your file name dot whatever the file type is will just create a new file. Well, it's how we're going to create a new file from Git bash when we have our folder that will become our repository. For configuring your user information for your repository, this basically attaches a name and email to your commits and everything that you do to the repository. So that's just git config global username with your name in quotations, git config global user email with your email. And then for starting a new repository, git init is the command that we use. This does nothing to GitHub. This is basically just you initializing a new repository only on your computer. And then for making changes to your code, git add, it basically brings the changes you made to Git's attention and puts them in a sort of staging area, so that way you can decide when you want to officially implement those changes later on. Git status shows you all the new files, all the changed files, what has not been committed yet. And git commit is how you officially say, okay, Git, save these in the version history. Well, save whatever is going on with my code right now in the version history of my code. And then finally, git remote add origin is what we're going to use to interact with GitHub and Git. Git remote add origin is how we're going to link the local repository on our computer to GitHub. And whenever you have a new repository, you only have to do this once to connect Git and GitHub to each other. And then git push, whenever you finally make your commits, all your changes, and you want to make those changes visible on GitHub, I picture it as like you push it up to the internet. And then, yeah, we'll also go over git pull, which is basically when changes have been made to a repository on GitHub, say by other people, and you want the latest version of the code, you pull it down from the internet to your computer, so you have all those changes. And the last command we'll go over later is git clone, and that basically is how you would make a copy of another project on GitHub if you want to play around with it or learn from someone else's project. And yeah, it'll give you your own copy on your computer, won't affect their version of the code on GitHub or wherever else they have it. So yeah, we did go over at the beginning installing Git. So for Windows, there's a URL you can go to, Mac URL. Fancy Linux people, there are package commands you can use. And yeah, when you're installing, just leave all the options as default. And then text editor, I just think this will be a better way to show how you would say edit your code and then actually keep track of all the versions of it and get it on GitHub. So we'll just be editing probably just a text file in one of these text editors. It doesn't matter which one you choose, just pick one and you're good to go. And now we will switch over to actually using Git and GitHub. So when you have Git installed on your computer, the first thing that we're going to do is to just create a new folder on your desktop. I'll just call it my folder. And then from that folder, we just want to right-click and click Git Bash here. And that will open up the area where we're going to be inputting all of our commands to use Git and to push to GitHub. So first, we'll just check the version of Git we have installed to make sure that it actually installed. So that will just be git space 2 dashes version. And my version's probably different than yours since I didn't just install Git, but it should tell you what version of Git you have installed, and we're good to go. So the first thing we're going to do is to create a new project, which, okay, we started with creating the folder on the desktop, did that slightly out of order. But from there, we can, since we're already in the folder we just created, we can just create, say, a new text file. So we'll do that with our touch and my file, or whatever you want to name it, .txt for text. And then from there, Let's create like 2 more files so that way we can see how different files change. So we'll also do like touch, file 2, text. These can be of any file type, which is how you're going to get like all the different files that make up your project into your repository. So we can also do like touch file 3.html. Oh, sorry about that. Okay, in that case, is that better? Helpful?
The text size.
Uh,
It should be control plus.
there we go. Okay, good. Okay, then I'll just go over what I just did since nobody could see that. Okay, so the first thing we did was just checked the version of Git we have installed to make sure it was actually installed. So we just typed git space 2 dashes, then version, and then the version of Git that you have installed should come up. Then after that, since we already made the folder on our desktop and then we right-click to git bash here, we're already in the right directory, which is the folder we just made, and now we just wanted to put some files in that folder. They can be of any file type. That's pretty much representing like all the files that are going to make up your project when you have like, say, .c, .py, or whatever types of files you have that make up your code. So for examples, we just added 2 text files and an HTML file. So I just named it like my file, file 2, file 3. Before that, you want to type touch, and then your file name, dot the file type. So then from there, we have a folder, we have our files in it, so now we actually want to create a repository of this folder. So you want to type git init, and that will initialize, say like this folder as a repository for our project to hold all our files. And now we're ready to start using git commands. Oh no. Okay, so now that we're ready to start using git commands, we can actually configure the name and email that we actually want attached to all the changes that we make. So that will be git config, 2 dashes, then global user.name, and then in quotations, your name, Jennifer Droke. And then from there, we want to configure the email address attached to everything. I would recommend using the same email that you use to make your GitHub account. So that's git config, 2 dashes, global user.email, and then my email is very long, but that is the email affiliated with my GitHub account. All right, and then after we configure those things, then we can start looking at what is in our repository. So git status will show you all the files that Git is aware of in that folder. And as you see, our 3 files we made pop up in red. Basically, that means that those things have not actually been added to our staging area, like the "Are you sure you want to commit these changes?" Nor have they been committed at all. So to commit those things, first we want to say git add to add them to the staging area. If you only want to add, say, 1 file at a time, you can just do git add, and then my file.text. And then we can do git status again. And you see that my file.txt is now in green. It is actually in the staging area. The other 2 files, Git's still not keeping track of them yet. But we'll just go ahead and make sure that all our files are being kept track of, or being tracked. So we'll say git add. And then if you just do a space and then a period, that will make sure that all of the files that Git is currently not tracking are actually being looked at. So then git status actually reflects that, and everything's in green. So we're all good now. And I will mention that at the end. So then, say we want to edit one of our files. So we're going to minimize git bash for a second, go to that folder we created on our desktop. And as you can see, we had created an empty folder, but now all the files that we just created through bash are actually in this folder. So we'll just right-click on one of the files, right-click on one of the text files, not the HTML file, so we don't have to deal with HTML right now. And then we'll just go to open with. And then you just want to choose whatever text editor you have installed to open that file. So yeah, I'm using Sublime. And since this is a text file, we can just type a line of text or so, like this. I'm guessing that's really small for everyone to see as well. There we go. Okay, so yeah, this is just one line in a text file that we opened in Sublime, and this is some stuff. That's not how you spell stuff. Okay, and then you can either go File Save or Control S or whatever you use to save that file. So yeah, that file has been saved. Our edits to that file have been saved, and now we want to make sure that Git knows that we made changes to that file. So then we can do git status again. And as you see, Git notices, hey, you modified a file that I was aware of. So then, once again, you would just do git add. We'll just do the space, then period. So that way, Git will add everything to the staging area that is not currently there, even though it's just one file. And then from there, we can officially commit our changes now that we've seen how you make an edit to a file, how you bring it to Git's attention in the staging area. So then from there, we can do git commit to like officially make Git aware of these changes and save them in our version history. And what we're also going to add to the end of this git commit command is a space, then a -m, then another space, and then in quotations, some comment on what the changes you made are and why you made them. And that's basically just your documentation to keep track of what's going on with all the changes to your files. So we can say we made some files and edited them because necessary, or whatever more valid reason you have for making changes to files. And then as we see, 3 files changed, and then our commit actually worked. We made some files because necessary. And that's basically how you would actually save whatever version of all your files for your code are in Git. So then we can once again look at git status. And as you see, since we actually committed all those changes, Git's saying there's nothing that you've modified that you haven't brought to the staging area. There's nothing in the staging area where we need to know, are you sure you want to add these changes to your version history? But say we go back to another one of our text files. Oh, I didn't want to open that in Notepad. Open with Sublime. And we say another change to file and more changes. And we save that. Then if we run git status again, we see once again we have another modified file, so we can just git add then we can just do git commit. Well, we can do git status again to see that it's added. Git status. And then git commit. More changes, cause yeah. And then git status will show that we've committed all the changes made to our other text document. So the next thing I wanted to go, well, first let me make sure that everybody is on track. Anybody have any questions? Anybody just completely lost?
When you issue the commit command, does Git automatically give it a version number?
Version number, I'm not sure. Yes?
Yeah.
Okay.
Yeah, so we'll make a section of the shop that you can reference.
The just feeding all the files and crunching into some sort of side manipulator?
That actually takes some changes. So any changes that we made, we'll delete the changes, and then it'll hash those, and then it does a bunch of sample stuff instead of shop.
Yeah, and for everybody on the stream, that question was, so basically when you commit your changes, does Git like automatically assign a version number to whatever version of your code that is? And yes, there is a way for you to reference like what version of your code that is later on. Okay, so from there, the next, I'm sorry. Yes, I was actually, I can show it to you guys now, but I was also going to post that at the end. GitHub has created this beautiful cheat sheet of all these commands, so you don't have to memorize them. It covers a lot more commands than we're going to go over, but they're pretty simple to pick up, like as you need them. And yeah, believe me, I even look at the cheat sheet because it's helpful. So the next thing I wanted to go over after we actually see how to make changes to a file and commit those changes is how to make a branch. So a branch is pretty much what we talked about, how you can work on code without affecting your beautiful main code that you don't want to break or destroy catastrophically. It basically creates an alternate timeline that you can work on to like make whatever changes you want, experiment with some things, and then when you're ready, you can say, okay, all these changes are good, it's not gonna break everything, so just put this branch back into my main code to add like whatever changes I made. And yeah, you know they work without breaking your main code. So to make a branch, you just want to type in git branch, and then whatever you want to name the branch, we'll just call it my branch. And as we see, we are currently in my folder with master out here, and master is what's called like your main branch of your code. It's basically like all the files that you initially committed and whatever versions they are, that's your master. And then when you said git branch my branch, you created a branch called my branch where you can see this is what happens when you try to just make a visualization of what it could look like. It's like if this is master, this is my branch that you just made. And it gives you like that alternate timeline to play on. When you're ready, you just implement it back into master. But we do have to switch over to that branch we just made, because right now we'd still be making changes to master. So to switch over to that branch, you want to do git checkout, and then whatever your branch name is, my branch. And as you can see now, master's gone, my branch is here. You'll actually be making any changes that you make to that branch, and it won't affect your main code. Nothing breaks, and you won't cry when your final project's due and you didn't use version control. Clearly there's a story there. So from there, we can just say add a new file. You can do the exact same things we just did in master. So we can add a new file, for instance, like touch file 7.txt. And if you go back to, is the folder actually visible to everyone? Sort of? Close enough? Sorry about that. That's not really getting much. Okay, there we go. Okay, so how we just did touch file 7.text. So we just created another text file, file 7, that is kept track of in our project. And then from there, we can say open file 7 in Sublime Text or whatever text editor you're using, and we can say we made a new feature. And just save that. And we can close it. And then once again, if we check git status, we see that we created that file 7. We can then do what we did before. We can add it to the staging area with git add. And we can say file 7.text. And then from there, git status will then show us it's in green, it's in the staging area, and then we can just do git commit made a new fancy feature. But we're excited about it, so exclamation point. And then that file has been actually saved in our version history, all the changes to it have. And then whenever you're done making whatever changes you made in that branch of your code, then we can switch back to the master branch. So we're going to use the same command that we used to switch to my branch. So let me show everybody again. With git checkout my branch, this time we're just going to say git checkout master. And as you see, we're switched back to master. Then from there, okay, say we switch back to master and all the changes that we made to my branch are exactly how we want them to be, and we think, okay, it's time to add that to our master branch to just merge all of our changes together into one beautiful working code. So then we can use the command git merge, and then our branch name, my branch, and then once again, the same formatting we used for putting a comment about what changes we made. When we committed, we can just do your -m, your quotations, this added a new fancy feature. And then we have officially taken all the changes we made in the my branch that we did safely without breaking master branch's code, and we just implemented them into the master branch so that way anything new we added is in master in one beautiful working code.
What if you had to make changes to your master and you wanted to merge things to your branch? Can you still do that?
Could you? I've never done that for any reason, but I guess you could.
Yeah, it's called remixing. So basically, you've got this basic code. So like you've got your master stuff. And someone makes changes over on master and you want to make sure code reflect in your branch. You rebase master from that branch, and it will basically replay everything that's happened on master on top of it.
Cool. And yeah, oh, did you have anything? Yeah. And everybody watching the stream, the question was if you have made changes to the master branch and you want to make sure those changes are reflected in, say, my branch or whatever other branches you've created, you can also do that. Like, say if somebody made changes to master, but you're working on a branch, but you need those changes in that branch, you can also make sure that master's changes are merged into that branch that you made. So that covered the basic commands I wanted to cover just using Git on your computer. So now we'll actually see how all of this works with GitHub. So, is this big enough? Yes? No? Better? Okay. So the first thing you want to do, if you haven't already, is to create a github.com account. Just go to github.com, sign up. I'll just go ahead and sign in. And then okay, once we're signed in, we want to create a new repository. So if you go to the upper right-hand corner of the page, and then you click the plus sign, then we'll click New Repository. We can name the repository my repository is how you spell repository. You can give it a description if you do so desire. GitHub also gives you the option to make those repositories public or private. Public, anybody can see that repository, but you choose who can actually make commits to that repository, but anyone can definitely make their own copy of that public repository. The private repositories actually cost money. There is a way around that. If you have student credentials, you can actually have free private repositories through your student email. So I'll provide more details on that and some other resources if you have student credentials at the end. But we'll just go ahead and make our repository public. You do typically want a README, but we're not going to initialize this repository with a README. Your README file is basically a markdown file. Markdown is the format that you use to actually make everything look nice and pretty for your README. And your README just provides more information on your entire project, especially helpful for other people looking at your project. For me, I forget things like my memory's been erased, so that's also helpful, like 6 months after I've looked at a project last. So we'll just make it public, not initialize with a README, create a repository, and then from there, this is basically just giving you the steps that you would have to follow to have created the repository on your computer and then actually create the repository on GitHub and then connect the two. But the line that we want is the git remote add origin. One of the commands I mentioned in the beginning, instead of typing it, we're going to copy and paste it because it also provides the URL to the repository on GitHub that we want actually connected to Git. So we will take the git remote add origin, go back to git bash. I will say first that we want to type git, R-E-M-O-T-E, git remote. And we see that we have, like, when we typed in git remote, we see that nothing came up. Oh. And then when we paste in the git remote add origin with our URL for our repository on GitHub, and then we type in git remote, we actually see that something happened and that Git on our computer and GitHub are actually connected now. So then we can actually push our repository to GitHub, the repository on our computer to GitHub. Like I said, basically if you have your code on your computer, you want to push it to the interwebs, and that's how GitHub gets the latest version of your code and all the versions before that. So we will do git push. That's not how you spell push. Git push, then a space, then dash u, then origin, master. And this could take a while. I did not have to log in this time because I have already logged in, but you should have a window pop up that asks you to log into GitHub to actually verify all your credentials and your account information. And that's once again just your username or your email and then the password you use to create your GitHub account. And I'll give everyone a little bit to get that done. Everybody good? Any questions so far? Are we all good? All right. And then from there, we can go back to GitHub to our repository. I just clicked on my repository at the top here. And you actually see that all the files that we created on our computer and had in our repository on our computer are now on GitHub. And now I guess I'll just show how to just create a file, commit those changes, and then push that file to GitHub, just one after another, a bit faster than we just did through all those examples. So we'll create the README that we didn't initialize this repository with. So we'll use touch, README. This one's going to be a markdown file, so you want .md at the end instead of .txt. Then once again, if we do git status, you see that we have a README file now. So then we'll just add it to the staging area with git add. And then from there, git status will show that we actually have that file in the staging area. Then we can do git commit. We made a README. And then that file has been committed. And then to get that, as we can see, if we switch back to GitHub right quick, refresh, still no README, but then after we do that is not how you spell push. We're going to once again do our git push u origin master. So git push u origin master. That is not how you spell push. Darn it. Git push u origin master. Spell check. And then, once again, if we switch back over to GitHub and refresh it, we see that our README has been added to our repository. And very quickly, I will just give a little more information on how to clone a repository. That pretty much, what we just did pretty much covers all your creating files, your editing files, your committing those changes with Git, and then pushing it all to GitHub. So now I'll just go over cloning a repository. So basically, if you just, I'll switch to a different repository and show that. You guys can just do this with the my repository we just created, but I'll go to like React heat map or some other random repository. And then if you go to the green button, clone or download, and you copy this link, then we can go back to git bash and we can type git clone, and then we paste in the link we just copied. And that will clone that repository to your computer. I must actually go back a step because I did not actually get out of the folder that our repository was in. Whoops. I was supposed to try to go back to desktop and then from there actually just clone that repository as a folder on our desktop so that way it's nice and neat. So, sorry everyone. If I confused anyone, just let me know after I go over this. So I meant to just go to the desktop as a directory. Okay, yeah, I'll go ahead and show this. Let me know if anybody gets confused by this. So we'll type in cd, change directory, and then we'll type in quotations, and C, and then capital U, users, and then your name or whatever your username is for your computer, Jennifer Droke in my case, and then slash desktop. No. And then from there, oh no, CD, C.
The tilde. If you use the tilde, it'll bring you directly to your home directory.
Did not know that. Which would have also been tilde/desktop. But yeah, basically we just did change directory, and then we made sure that we switched over to our desktop. We're out of the my folder repository. So then you would actually want to do git clone. And then paste that link. And then if we go to our desktop, which might still be very tiny and camouflaged on my desktop, but the repository that I just cloned and said to put on the desktop is actually all here on the desktop with all of its glorious files. Did anybody get confused in that? Because I briefly did. Okay, good. And then the last thing I'll go over is git pull. So basically git pull is what you use, like say if somebody made changes on GitHub and you want those latest changes in the version that's on your computer, use git pull to pull all that information down from GitHub to your computer. So, when you're in a repository, which we're in desktop right now, so I'll do, yeah, I'll go ahead and do this again. Let's go ahead and go into a repository by going back to our desktop. We'll go to the My Folder repository that we first created, and then we'll just go git bash here. And then when you're in a repository, you just want to type, oh no, it got small again. There we go. And then we'll just type git pull. And then it tells us it's already up to date because we have exactly the same version of this repository on our computer as the version that is on GitHub. But if any changes were made to GitHub, it would actually reflect that it pulled all those changes, and that's the version of the code that you have now on your computer. So the last thing I'll go over, that covers our entire tutorial. Did anybody actually have any questions? Get confused? All right then.
I just have a question, and it's more like a GitHub thing. You said git pull, and you didn't have to provide the URL, so somehow it knows where that URL is?
Well, it's because where we had actually linked Git and GitHub, like the repository we created on Git with the repository we were in on our computer. And since we had opened up git bash in my folder, the repository we had created, when you do git pull, it already has that information knowing that's a repository that this is linked to on GitHub. So just pull those changes to this repository that we're in here. Make sense? Cool.
So why should we use version control instead of just managing files or sort of losing on a computer?
We should use version control because instead of just managing, I missed like the last half of the question.
Yeah, so instead of like, so you've got lots of folders and stuff, why should we, basically why should we use version control in general?
You should use version control in general because, okay, frankly, and just managing files on my own manually, sometimes you still make mistakes, you still override your code, you still accidentally delete files and files still just disappear when you have projects due, and it's terrible. Also, when you're working with other people, Git still allows you to each do that on your own devices, and it makes sure that you know all the changes that are being made to get a full picture of your project, instead of you having to try to figure out how to communicate with each other to know what changes did you make to this file, should I do this, will this mess up your thing? So yeah, it gives you just a better way of controlling what everyone's doing at once and gives you a full picture of the project without having to do all that work yourself. Is that a satisfactory answer, Carson? Okay. And then the last thing I'll do is just show everyone some resources. and I will post these in the Slack as well. So the first one is the GitHub cheat sheet. Thank you, GitHub, for this. It provides a cheat sheet of all of the commands that we used, and then some. We did not go over nearly all the commands that you could use with Git and GitHub. Other resource that I will provide is GitHub's tutorial on creating a pull request on GitHub. Basically, your pull request is once you've made changes to say your copy of the code and you want someone to implement your changes into their code, you can create a pull request on GitHub and actually see if they will implement your changes into their code. So I will post a link to this. This tutorial actually has you join a class repository on GitHub that will walk you through adding a file to this repository, creating a pull request, and having those changes implemented into this repository. And the last thing I will pull up is the educational resources. If anybody has an educational email that they would like to use for free private repositories. Okay, so GitHub Student Developer Pack provides a lot of tools free of charge that would otherwise cost money. It provides a lot more than just, say, free private repositories. You can get Unreal Engine, Git Kraken, a lot of different things. And the GitHub was actually what I was talking about, where you just get unlimited private repositories. Normally it would cost something every month, but as long as you're a student, GitHub will give you unlimited private repositories. I'll also post this link in the Slack, but yeah, you just go to Get Your Pack and then log into GitHub and potentially fill out more information on that. And then you'll be able to get all that free stuff. And that's pretty much all I had to go over, a few resources and basic commands in Git and GitHub. Did anybody have any other questions that I could answer or that Carson can answer better, because Carson can answer them better?
Someone on Twitch asked about comments, so commit comments.
Mm-hmm.
How to write good ones and what the purpose is. So when you're committing the comments you make.
Yes.
What are those for and how do you write them?
Okay, those are basically so you can keep track of why certain changes were made and what specifically they were. Basically a way for you to actually communicate and also keep some written documentation on why you made those changes. And the way we did those actually, well, it's not here, but when we did git commit -m, and then we had some stuff in quotations, this was actually our comment on that commit and what changes were made. So typically here's when you would want to say, I made this change because we needed a photo carousel on the website, or whatever else you added. And yeah, here's specifically what I changed, or any other information that you think needs to be communicated about that particular commit.
I have a question on that. Can you point to a file as a comment? Like a file that have a lot more text in it, or is it just?
Can you point to a file as comment? I wouldn't do that, I don't think. I'd probably include all that in the README, like when we made the readme.md. That's where I would include a lot more details about the entire project or any other files that should be referenced in regard to another part of the code. Yeah, these are just quick, short messages about, hey, I made this change, you know what it is.
What's the best practice on frequency then? How often should you be committing? Because you don't want to start from the beginning and then do all of these crazy.
And then commit your entire program. Yeah, so that question was, what's the best practice on committing? I usually do it, I kind of in blocks whenever I feel like whatever change I'm going to make after this could just potentially destroy everything is when I commit. Basically, yeah, basically whenever you just feel like after this will be the point of no return. So let's make sure this is saved. So save about as often as you save like your Word document or whatever, so you don't lose things or don't mess up previous things. So, any other questions? Yes. We will definitely look at that. All right, I think we're good. That covers everything. Yes, thank you for having me.